Hi everyone, today's video is all about section 1.3, which is all about lines. Lines again is something you have seen in the past or should have seen in the past. So again, this is a review. I will not go into great detail on all of the little things, but I do want to hit the high points. So first of all, a line does have a bunch of different forms in which the formula can show up or the equation can show up. And the first one is probably the most remembered, and that is your slope-intercept form, which looks like y equals mx plus b. And in this equation, y and x are variables. M represents your slope. And if you remember, slope is your rise over the run, or sometimes referred to as the change in y over the change in x, or sometimes we see it as y2 minus y1 over x2 minus x1. So that's some of the things we see our slope for. The other piece that's in here is that b, and b represents that y-intercept, where the graph or where this line crosses the y-axis. So y equals mx plus b, slope, intercept. That's the name of the form because we need the slope and we need the intercept in order to create it. And m is your slope, b is your intercept. Another one useful form is our point slope form. And here we need a point. So a point, call it x1, y1. And again our slope, which is m. And then our equation will look like and this is used most of the time when we have a point and a slope and we want to get the equation. We don't usually have it in this form given to us, but we use this form to get the equation given a point and the slope. General form is what we usually see, and general form is, looks like ax plus by plus c is equal to 0, where a, b, and c are simply real numbers. They have no representation to the line itself. So general form is the easiest to type, hence the reason it's used a lot in textbooks, but it is also the most not as useful as the other two. In other words, we can't pick off any information from it, so we need to take that general form, put it into one of the other forms, usually the y equals mx plus b form, so we can pick off the information and then possibly graph it. So we're going to do that. Here's an equation. 2x minus 3y minus 12 is equal to 0. That is in general form, and we want to find our slope, find our y-intercept, and we're going to graph it. So we're going to find the slope, find slope, y-intercept, and we're going to graph using all of that information. So what we're going to do is we're going to put it into that slope-intercept form, in other words, solve for y, so we can pick off the slope and the y-intercept. So I'm going to add 12 to both sides as well as subtract 2x from both sides. So I am going to subtracting the 2x and adding my 12 to that other side, or to both sides actually. And now I'm going to divide everything by a negative 3. And when I divide a negative by a negative, it becomes a positive, so 2/3. And then dividing this 12 by negative 3, we get that minus 4. So our slope is 2/3. The y-intercept is negative 4, or as a point, 0, negative 4, because it does represent a point. And now I'm going to do a rough sketch of this graph. So put some axes in here, some hash marks in here. Okay, so I'm going to start at the y-intercept, 0, negative 4, so there it is right there. And I'm going to use my slope, and I'm going to then draw another point, and then I can then draw the line. So my slope is rise over run, so I'm going to rise 2, run 3, so rise positive 2, running 3, put another dot. I can do this again, 1, 2, 1, 2, 3, put another dot, and then I'm going to connect the dots. And of course this is a straight line, so I will put the arrows on the end to indicate that it does keep going. Alright, so that's a little bit of a reminder of some of the things that we have in lines, but there's more. And a classic problem is to talk about how to find the equation of a line that goes through the point that is parallel or possibly perpendicular, I'll talk about perpendicular in a second, to this line. So if you can remember, we have slope-intercept, we have point-slope. I'm going to use the point-slope form in this problem to help me. But first I need the slope. So if two lines are parallel, they will have the same slope. So what I need to do is find the slope of this thing and realize that the line I'm coming up with will have its same slope. So to find my slope, again, I'm going to need to solve for y. So I'm going to move my 4x and my 5. So I'm going to subtract 4x from both sides and subtract 5 from both sides. And then I'm going to divide everything by 6. And as I do so, I will reduce. So dividing by 6, dividing by 6. My slope here is a negative 2/3. So since these are parallel, the slope of my line will also be 2/3. Just as a side note, if they were going to be perpendicular, that means they have the opposite reciprocal slopes. So in this case, the opposite reciprocal would have been, our new line would have had a slope of 3/2. So not negative, but the opposite of a negative is a positive, and then the reciprocal, 3/2. But we wanted to be parallel, so we're going to go back to this 2/3. So that means my m is a negative 2/3. The point that it's going through is 1, negative 2. Now the formula was y minus y1, so y minus a negative becomes plus 2 equals our slope times x minus x1. So there is an equation. If we wanted it in useful form, we like to solve for y. So we're going to distribute that 2/3 through. We a lot of times like it in our y equals mx plus b form. So this gives me a plus 2/3. And subtracting 2 from both sides. So that would be like minus subtracting 4 or 6/6. So I get a negative 4/3. There, 6/3. If I wanted to put it in general form, first thing I would do is clear my fractions. So multiply everything by 3 and then move everything to one side to set it equal to 0. But clear the fractions and then go from there. Two more little things to remember, that vertical lines and horizontal lines have special formulas. So I'm going to draw a vertical line here. Get a color here, put it in green. So let's say I have a vertical line, and we'll put it, that's going through that value there. So if you look at any point on this line, they all have one thing in common, namely the x-coordinate will always be 3. So a vertical line will have the equation x equals 3. The slope of a vertical line is undefined. Undefined. If you tried to calculate it using the slope formula, change in y over change in x, you're going to be dividing by 0, which we cannot do. So we say the slope is undefined. It's so steep we can't measure it. So that's why it does not fall into our y equals mx plus b, because there is no m. A horizontal line does fall into that category, but it still takes on a nice form as well. So I'll put this one down here. Okay, the slope of a horizontal line, our slope, m, is equal to 0. There is no slope. It's said to be completely flat, no positive nor negative. And if you look at any point on this line, the y value does not change. Also, in y equals mx plus b, the mx piece will disappear because it is 0, and you'll just get that y equal to b. And in this case, that intercept is -2. So the vertical lines have the equation x equals something. A horizontal line has the equation y equals a number. So hopefully that brings back all the things that you remember about a line. The next video will be on solving quadratics.